Hi, my name is Matt Pichet. I'm a biologist and I work as the Natural Resources Coordinator within the Department of the Environment and Natural Resources for the tribal government of the native village of Eyak in Cordova. I'm here today to provide an overview of the native village of Eyak Salmon Research and Monitoring Program. My position is supported through the Office of Subsistence Management Partners for Fisheries Monitoring Program, and our current fisheries research and monitoring projects are funded through competitive grant awards from many agencies, including the Office of Subsistence Management, the U.S. Fish and Wildlife Service, NOAA, and the state of Alaska. If you have questions, I encourage you to leave it in the chat box, and I'll respond during the 10 to noon session, or swing by the NVE office on Nikolaff Way, across from the Fisherman's Memorial. Come upstairs and ask for Matt. And as always, feel free to send me an email or give me a call on the phone. My contact information can be found on our website and within the information provided below this presentation. For many of these slides, I'm going to take away the screen that shows me so that way you can read the whole slide, but I'll pop in and out from time to time. So I'll start by introducing you to NVE's longest running fisheries monitoring project, the Copper River Chinook Salmon Escapement Monitoring Program. This began with a feasibility study in 2001, and by 2003 was fully vetted and being used by state and federal management agencies to monitor Copper River Chinook salmon population status and run performance. This study is responsible for estimating the in-river abundance of Chinook salmon at Baird Canyon on the lower Copper River on an annual basis. Methodology will be discussed in the following slides. The study uses research fish wheels and 2 sample marker capture techniques to estimate population abundance. The Copper River has ideal conditions for this type of study. Similar methods are in use on the Taku, the Nass, and the Fraser Rivers in British Columbia. For a simplified introduction to the mechanics behind a marker capture study, we first start with the population of fish. Let's assume it's impossible to count every fish in this population. Perhaps the river's too big to put a weir across it, or too silty to count fish from the air. Therefore, it forces us to use statistics and to sample the population to determine the population estimate. To conduct a mark recapture, we must first sample a representative portion of the population. In this example, the blue circle represents the portion of the population captured. The red X is our mark, or tag, that we apply to the fish captured. This is known as the first sample event of the 2-sample mark recapture methodology. All fish captured in the first event are tagged and released. Following release from the first capture event, the marked fish mix with all of the unmarked fish as they continue their upriver migration, providing you with a population of mostly unmarked fish, but with a sample of that population containing marks. In the second sample event, represented by the circle, a total of 10 fish are captured, of which 3 have marks that were applied in the first sample event. Using the simplest form of a mark recapture equation, marked fish multiplied by fish captured in the second event, divided by the number of marked fish captured in the second event, equals the population estimate. In this case, 6 salmon were marked at the first sample event 2 slides ago. They were then released, migrated upriver, and mixed. 10 salmon were captured in the second sample event, represented by the circle on this slide, of which 3 of those fish had marks from the first marking event. This gives us a population estimate of 20 fish. Now in reality, the true population size on the screen, if we count them all, is 19 fish. But this example demonstrates the basic concept of a marker capture study. And remember, this provides an estimate and not an absolute count. We use more rigorous statistics on a larger population, and we can account for temporal variation through pooling and stratification. Statistics allow us to report error within the abundance estimate, and our assumption tests allow us to assess our confidence in those results. This gives you a general idea of how a mark recapture study works. When conducting a mark recapture study, there are several conditions that need to be assessed. We address these statistically with assumption tests or through our study design, which was developed using accepted techniques, peer-reviewed research, and laboratory studies. However, there is inherent uncertainty in any population study where handling is required. While we try to minimize all handling and capture effects, some aspects remain untested, such as the migratory behavior and migratory speed of untagged fish. Because unfortunately, we have no way to determine things like migration speed without first handling and tagging a fish with a transmitter. For our mark recapture study on Chinook salmon, we operate 2 camps on the Copper River between Cordova and Chitina. Baird Canyon is our lower river tagging site, which represents our first sample event. Baird Canyon is located just upstream of Miles Lake and Abercrombie Rapids. Here we operate 2 fish wheels 24 hours a day from ice out in early May through mid-July when the Chinook salmon run ends in this portion of the river. Our second sample event is located 90 river kilometers upriver near Canyon Creek, just below Wood Canyon in the village of Chitina. This site is located below the lower boundary of the Upper Copper River District fisheries. Here we operate 2 fish wheels 24 hours a day from mid-May through late July when the Chinook salmon run slows in this portion of the river. Our remote field sites and fishing sites are on Eyak, Chugach, and Otna Corporation lands, within the traditional use area of many Copper River tribes who have documented a long history of use. Many local tribal members have contributed substantial amounts of traditional knowledge, technical expertise, engineering, hard work, and long days on the river or in a workshop to help make this project successful. A few important things to note about our camp locations. There are no major fisheries occurring between these 2 camps. There are no documented Chinook salmon spawning grounds located between these 2 locations. Therefore, the same population is available for capture at both locations, making this mark recapture study feasible. This is a very remote section of the watershed with few visitors outside of rafters floating the river. This is a challenging place to work, but it has resulted in substantial capacity at NVE to conduct remote fieldwork safely and effectively. Here are 2 photos showing our biologist and fish techs sampling Chinook salmon on a research fish wheel in Baird Canyon. First, we retrieve the Chinook salmon from the live tank using a dip net with knotless nylon web. The fish is moved to our flow-through suspended gurney sample trough to be sampled prior to release. At the first sample event in Baird Canyon, sampling consists of application of a primary mark in the form of a dual T-bar yellow filament tag with a pit tag encased inside the filament. The pit tag rapidly assigns a unique ID to the individual fish. So when recaptured by our fish wheels or harvested in a fishery, we know exactly when that fish was tagged at Baird Canyon. There is also the NVE address and phone number printed on the outside of the tag. We then apply a hole punch in the operculum on the right side of the fish so we can ID it as a tagged fish in the event that the yellow tag is lost. We take morphometrics, which is just a fancy way of saying we take some measurements. We look for an adipose clip, and then we release the fish. At the second sample event below Wood Canyon, we inspect all Chinook salmon for a primary and secondary mark. We measure the fish, place a left operculum hole punch so we can identify that fish upon recapture, and then we release it. And we repeat 24 hours a day, May through late July. Here you can see the yellow tag just below the dorsal fin on the fish. That's the external tag. Inside that yellow tag, there's a tiny little pit tag that has a unique ID on it. This fish is at Baird Canyon, so it would have received a right operculum hole punch. Here is the operculum hole punch. And again, as I said before, Baird Canyon receives a right hole punch, Canyon Creek a left hole punch. This allows us to identify recaptured fish regardless of primary tag loss. It also identifies the site of capture. We have specialized gear that makes this all possible. The photo below on the left shows our escape panels. These allow most of our bycatch to escape the live tank while retaining Chinook salmon greater than 500 millimeters total length. This is critical because anywhere between 95 to 98% of the salmon migrating through the Copper River from May to the end of July are actually sockeye salmon. Only a small portion are Chinook salmon. So this allows the majority of the bycatch to escape, while retaining the majority of the Chinook salmon. Just to the right of that photo is a picture of our tags. These are those yellow polymer tags that I was talking about. They have two T-bars, that's what we call them, two little T's, that actually are inserted through the dorsal pterygophores, which is a fancy way of saying the spine that comes down from the dorsal fin inside the body, and they lock behind the opposite side. So that way they're retained, and even when migrating through the Copper River, these don't pull out. In the event it does pull out, though, remember we have that backup mark in the operculum hole punch. The other photo on the page shows our sample troughs. These troughs consist of a vinyl gurney that flexes as the fish moves. The gurney is suspended, so the fish isn't in contact with hard aluminum. We use a bilge pump to continuously pump fresh water through the troughs, and eye flaps decrease the amount of light in the trough, which helps calm the fish as it's sampled. We can conduct all of our sampling with the fish in the water and body supported by the vinyl gurney. A full sample lasts around 45 seconds from dip net to release back into the Copper River. Our crews are trained to handle fish appropriately and minimize fish stress, which is critical. All of our data is uploaded daily to our FishScan website. Here the public can view summary data, and state and federal fisheries managers can log in and download the full data set at any point throughout the season. This figure summarizes project results from 2003 to 2021. This figure shows the in-river abundance estimate and its standard error in gray in the center of this figure. Population monitoring is critically imperative during periods of low abundance, which has persisted for the Copper River Chinook salmon population since 2008. The lowest recorded run size occurred in 2016, followed by 2021. Prior to 1999, reliable Chinook salmon population estimates do not exist, but from 1999 to 2007, annual run size averaged 82,986 Chinook salmon. Since 2008, average annual run size has been reduced by 43% to 47,398 Chinook salmon. This extended period of low abundance has been documented through population estimates produced by this study, directly informing both regulatory and in-season management to accommodate smaller returns with the goal of maintaining a healthy and robust spawning population of Chinook salmon on the Copper River. As you can see, the data set in this figure goes back to 1999. The first 5 years of abundance estimates were obtained by ADF&G through their DipNet mark recapture study in Wood Canyon. Starting in 2003, NVE's fish wheel-based marker capture study became the primary tool for this data. Prior to 1999, an aerial index, harvest data, and age class mixture models were used to track the overall health of the population. The addition of the in-river abundance estimate refined the Chinook salmon population data available for the Copper River. This data continues to be refined today, and as new technologies come online, this population data for Chinook salmon will continually improve in terms of accuracy and precision. The 2003 to 2021 data depicted here is the same as the figure on the last slide, but it will be easier to explain the relationship between the in-river abundance estimate, run size estimate, and spawning escapement estimate using this visual. The black line with circles represents the in-river abundance estimate that NVE produces. We add harvest from below Baird Canyon, commercial and subsistence fisheries in the Copper River District to obtain an estimated run size, which is represented here by the blue line. We can also subtract the in-river harvest from the in-river abundance estimate to estimate system-wide spawning escapement, represented here by the green line. In-river harvests include harvest occurring above NVE marker capture sites that occurs in the Upper Copper River District, which is state and federal subsistence fisheries, state personal use fisheries, and state sport fisheries. Looking at this figure, you can see the solid red line at 24,000 Chinook salmon. This was the Sustainable Fisheries Escapement Goal set by ADF&G in 2002. The escapement goal is reviewed at every state board of fish cycle, and in 2021, ADF&G recommended a change to the sustainable escapement goal to a range of 21,000 to 31,000 Chinook salmon, which is represented by the dashed lines. This is all critical management data that allows us to track the overall health of the Chinook salmon population, observe population trends, compare how Copper River Chinook salmon are doing in relation to the rest of the state, and it provides the data necessary to assess escapement goals and review them at every board of fish cycle. This figure brings all of the data from the past few slides together. Here you can see spawning escapement in blue at the bottom of the stacked bar graph, followed by commercial harvest in gray, personal use harvest in yellow, sport harvest in red, and subsistence harvest in green. All of this combined together represents total run size. This also demonstrates the response of fishery managers to decreasing run sizes. You can look at this by comparing pre-2008 and post-2008. In order to achieve sustainable escapement goal during a period of low abundance, harvest opportunity is reduced. In periods of high abundance, this harvest opportunity is increased. The data set on Copper River Chinook salmon is relatively small and rather narrow in terms of achieved spawning escapement. As the longevity of this data set grows, we should encompass a greater range of spawning escapements and the productivity responses associated with that level of escapement, allowing managers to continually refine productivity models, forecast models, and better understand the production potential of the Copper River watershed Chinook salmon population. Another study that we've been working on is system-wide distribution and stock-specific run timing of Copper River Chinook salmon. This is a collaborative study with ADF&G. Myself and Corey Schwanke with the Glen Allen Field Office at the Division of Sportfish are the two project principal investigators. This study ran from 2019 to 2021. We are currently finalizing the 2020 and 2021 data, but I'll overview the 2019 data in the next few slides, and please stay tuned over the coming months as we wrap up our analysis on this 3-year study. This was an easy add-on to the mercury capture study because the fish wheels were already sampling the population, and by adding a new tag, we were able to get a lot more data. This study was originally done in 2002 to 2004 by ADF&G and should be revisited every 10 to 20 years, or as you see changes within the watershed. For this study, we placed a series of 10 to 12 tracking stations along the Copper River and within the 6 major spawning drainages: the Chitna River, Tonsina River, Clutina River, Taslina River, the Gulcana River, and the Upper Copper Drainage. We then tagged between 650 and 750 Chinook salmon across the run with radio tags. These tags contain a battery and an antenna that actively transmits a radio signal. As the fish migrates upriver past tracking stations, the unique ID of the fish is recorded, as well as direction of movement. In addition, approximately 50 hours of aerial surveys are flown in a plane each year to search for the tagged fish and record their location as they migrate up the main stem to their spawning grounds throughout the entire watershed. In 2019, 59% of the 656 radio-tagged Chinook salmon were tracked to the spawning grounds. The remaining 41% were either harvested in the personal use, subsistence, or sport fisheries, were en route mortality, regurgitated their radio tag, or had a radio tag that failed. This photo shows one of our radio-tagged Chinook salmon. You can see the metal wire sticking out of the fish's mouth. This is the antenna that transmits the signal through the water up to the tracking station or up to the plane flying above. On the top left, you can see a photo of one of the radio tags in someone's hand, as well as the applicator that we use to put the tag into the fish. Down in the bottom right, you can see one of these Chinook salmon radio tags alongside a ruler. It's a fairly large tag that is inserted through the esophagus into the anterior stomach of the fish. This studies show that it has minimal impact on the fish. They are no longer feeding at this point in their life cycle. They are using their energy reserves to get up to the spawning grounds and spawn prior to dying. Here we can see 3 photos of the tag application process. It's important to align the tag properly. That's what this first photo on the left shows. That's the technicians lining up the tag with what we know about the anatomy and internal structures of the Chinook salmon. The tag is then inserted into the mouth, the applicator button is pressed on the end, and the applicator is pulled out. The tag will remain in the anterior stomach of the fish. These are the results from the 2019 study year and show distribution across the watershed. All of these little green dots are fish. All of the 2019 data was ranged within previous ranges observed outside of the Clatina River, which is a little higher in 2019. What we saw in 2019 was that 28% of the Chinook salmon returned to the Chitna River system, 24% returned to the Upper Copper River, which is everything upriver of the main stem confluence with the Gulkana. This includes the Slana, Chistochina, Gakona, Copper, and Tanata. 19% returned to the Gulkana River, 14% returned to the Clatina River, 13% returned to the Tonsina River, and 3% returned to the Taslina River. Another thing that this data provides is we're able to look at the percentage of spawners returning to the 9 aerial index streams that have been flown by ADF&G. These aerial index streams represent a very long-term data set on Chinook salmon. In fact, it's our longest running data set on Chinook salmon in the Copper River drainage. By looking at what percentage of our fish wound up in these clear water aerial index streams, it gives us an idea on how good they are at predicting overall abundance and what percentage of the population is actually utilizing these 9 clear water index streams. In 2019, 39% of our tagged Chinook salmon wound up migrating to one of these clear water index streams. And lastly, a neat piece of data is the cumulative proportion of passage past Baird Canyon by tagging date. In other words, stock-specific run timing. What time is each stock passing through the lower river tagging site? Here, we could see a bit of overlap between all of the stocks. However, the Upper Copper River, which represents the watershed's furthest migrants, passed through Baird Canyon the earliest. This is followed by the Gulkana-bound Chinook salmon, and then the Chitna watershed-bound Chinook salmon, and then the Taslina, the Clatina, and the Tonsina-bound fish had overlapping similar run timing. However, we do suspect that the Tonsina River population is underrepresented in the 2019 sample because we had to cease tagging operations early due to flooding at the site. So far, our preliminary 2020 and 2021 data supports this theory. In general, this does a really good job of showing you that stocks are arriving at different times, passing through the river, and ending at different times. This provides managers with the ability to change harvest pressure on particular stocks depending upon their run timing. One study that I want to mention is led by ADF&G. NVE is participating in this study, but we're a very, very small part of this overall study. And that's the ongoing coated wire tag study by the ADF&G Division of Sportfish out of Fairbanks. This study aims to provide data on Copper River Chinook salmon par to smolt in-river survival and smolt to adult ocean survival. This is the first time it's ever been conducted on the Copper River, and it's going to provide some really interesting data. As you can see here, all the way in the bottom left shows you the size of these little tiny coded wire tags. It's just a piece of wire with a unique code printed on it. Here up in the upper left is an example of one blown way up, but in reality you would need a high-powered microscope in order to read that code. And then on the top right you can see the size of one of those tags in relation to the snout of a juvenile salmon. So these tags are actually inserted into the snout of a salmon, it's retained throughout the entire salmon's life cycle. ADF&G is clipping the adipose fins on all of the Chinook salmon that are tagged with a coated wire tag. You can see it by following the yellow arrow. That fish there is missing its adipose fin. That indicates it's a coated wire tagged fish. Additional salmon work being conducted includes a pilot study assessing the use of current sonar technology to provide a salmon passage estimate on the Clatina River, which is one of the 6 major spawning drainages of the Copper River. NVE and the Anna Intertribal Resource Commission will be starting salmon counts this summer, and if successful, will provide a more refined look at the Clatina River system. Other systems being monitored on the Copper River include the upper reaches of the Gulkana River, Tanata Creek, and Long Lake in the Chitina drainage. The Clatina project will add a proglacial lake system to the current Copper River monitoring projects being conducted by others. We have also been funded to investigate smolt outmigration on the Clatina River. We will be attempting to capture outmigrating smolt this spring to assess the feasibility of a smolt abundance study to pair with the adult abundance study. If successful, this could provide the first recent sockeye salmon smolt abundance dataset. When paired with adult return data, it will help us answer important questions about productivity in the Copper River's glacial lake systems. We continue to add to the anadromous waters catalog. Our work puts us in remote areas where many undocumented salmon streams exist. Temperature monitoring is another low-hanging fruit. We are implementing long-term monitoring at all our research sites and hope to grow this long-term data set with partners from the Copper River Watershed Project and other tribal, state, and federal agencies throughout the basin. This highly successful and long-term salmon monitoring program has provided the opportunity for NVE to continue an integral role in Copper River salmon research and management data collection. The Copper River Chinook salmon has been utilized by the EX since time immemorial. Ensuring healthy, robust salmon populations thrive in the Copper River is an honor and a responsibility that we share. Thank you for your time. I would encourage you to reach out to me with any questions that you have. I'm always happy to chat about fish. If you have any ideas on ways to partner with NVE's research programs, I encourage you to reach out. Thank you for your time. Have a wonderful day.